Greetings and salutations, all those nice things. Welcome, everyone, to this lesson 4.6. We're going to have radical equations, but with multiple radical terms. What we were solving previously, there was only one radical in each of these equations, and the kind of core concept was isolate that radical term, square both sides to get rid of that radical, thereby turning it into a more familiar equation. And that was that general premise. In a case like this, we've got all our radicals on one side of the equation here. Isn't that kind of nice? And we could try squaring both sides. Just for funsies, let's do that. Let's see what happens. So on one side, how much room do I have here? About this much. So on one side, we've got the root of x minus 3. And we're subtracting 2 root x. On the other side, we've got negative 3. And again, I'm just going to try squaring both sides. See what happens. Right side, straightforward enough. Negative 3, you take it, you square it, you get 9. On the left side, we're squaring a binomial. We've got two terms. There's this first term, there's a second term. Remember that to square a binomial, you will have the square of the first term, which would just be x minus 3. You're going to have the square of the second term, and that'll be 4 times x. And in the middle, you're going to have 2 times their product. So we're going to have 2 times, let me write 2. 2 times the product of negative 2 root x and root of x minus 3. That's what we get when we square that whole thing. And we can simplify this, but at this point, we just acknowledge it's kind of yucky. It's not really something we want to deal with. It is technically, excuse me, it is technically doable. It is there is validity in proceeding this way, but things get a little gross a little quickly. So the recommended path to follow is this. If we have a radical equation where there are multiple radical terms, we're dealing with not just one square root, but 2 of them. First task is isolate and square one of the radicals, assuming we're dealing with a square root. So isolate, apply the necessary exponent. So we get 1 on its own, square both sides since we're dealing with square roots. And then, once we do that, we're going to be left with a situation that only has one more radical term. And that's familiar to us because that's what we did in the previous lesson. So we just kind of repeat that until all the radicals are gone. Like here. Well, that's the one we were playing with. We're not going to square both sides from the get-go. The first thing we're going to do is get one of these radicals entirely on its own. It doesn't matter which one. We can get this isolated, or we can get this 2 root x isolated. Choose whichever one's your favorite. I'd like to have positive terms personally, so I'm going to add 2 root x to both sides. So I'll have that. That means on one side we've got the root of x minus 3. On the other side we've got 2 root x minus 3. And at this point a radical is isolated. That one is completely on its own. The other radical is not isolated. That's okay. We've got one of them isolated. We can proceed from there. Now we can square both sides. On the left side, we're squaring a square root. They kind of knock each other out. We're left with just x minus 3. On the right side, we are squaring a binomial. We've got this first term, this 2 root x. We've got this second term, this negative 3. So squaring that, we've got the first thing squared. 2 root x times 2 root x is 4x. We've got the last thing squared, so negative 3 times negative 3 is positive 9. And in the middle, 2 times their product. So 2 times 2 root x times negative 3. We're going to get some kind of root x in there. 2 times negative 3 times 2 is negative 12. I could write that much more neatly. That works. And this one doesn't look quite as bad. We are now in a situation where there is only one radical term, but the process still applies that idea of isolate the radical, then square both sides. So we'll do that. Well, I think I'm going to add 12 root x to both sides. And I'm probably also going to subtract this x minus 3. So you can say we're subtracting x, adding 3. We're going to subtract x, add 3. Those are the things we're doing to both sides. The stuff in green, you don't need to show it. If it helps you keep track of what's going where, then for sure put it in there. Do note, if you show it on one side, you do have to show it on the other side. If you don't do that, then you've not shown the preservation of balance, and that's kind of highly illegal. I'll report you straight to the police for that. So again, you don't need to show it, but if you do, make sure you show it perfectly balanced. We don't want to put an imbalance into this equation. Simplifying. Left side, I've got 12 root x. Right side, I've got 4x minus x, so that's 3x. And 9 plus 3 is 12. I could square at this point. It's totally valid to do so. I'm just noticing that all my terms have a common factor of 3. So we might as well divide both sides by 3. And again, you don't have to show that. You just have to actually do it. And it'll make things a bit easier to work with. There's no more common factors, no way for me to kind of make this simpler to work with. At this point, I'm going to square both sides. Left side, we've got the square of 4 root x. That'll be 16x. Right side, square of a binomial, the first thing squared, the second thing squared, and in the middle, 2 times their product. Now this is just a quadratic equation, and we know how to solve that. Remember that all these radical equations that turn into quadratics must be solvable by factoring. I'm not going to give you one that turns into a radical answer, because those are a little bit more difficult to verify, and you do need to make sure you're verifying your answers. So it should be factorable. If it's not, one of us has done something wrong. So subtract 16x from both sides. We get this. That is factorable as the square of x minus 4. Therefore, x equals 4. I'd like to say that's the exciting conclusion, but don't forget, there's a little bit of an epilogue here. We do need to do one more thing. We've attained a solution, neat. We do need to verify it. You can do that on your actual test paper or quiz paper. You can do it on the side. Just make sure it's done somewhere. So, we're going to verify. We're going to verify the solution x equals 4. And remember, for this, we keep things separated into a left side and a right side. And for this, you can use any form of the equation before the squaring happens. So you could use this version that we originally have. The left side is the root of x minus 3 minus 2 root x, and the right side is negative 3. You could use this version where the left side is root of x minus 3 and the right side is 2 root x minus 3, but not including these squares, because it's that squaring that has the potential to introduce an extraneous root. Best, most consistent way to proceed, always just go with the original. So left side is the root of x minus 3 minus 2 root x. Right side is negative 3. And we're going to see what happens with that when x is 4. Left side is then the root of 4 minus 3, minus 2 root 4. And that's root 1 minus 2 root, 2 times 2. And we've got 1 minus 4. We've got negative 3. This works out. The left side is equal to the right side. If you want, you can put a nice little box around the answer to say, yep, that's super legit. And that is D-U-N, done. Things worth noting, this is a 3-mark question. You get 1 mark for squaring both sides here with 1 radical isolated. You get 1 mark over here for squaring both sides with 1 radical isolated. And then you get 1 mark for your method of attaining a solution. If there was an extraneous root, if you had to reject the x equals 4, that would be worth an additional mark. But since we don't, this is just worth the 3 marks. At this point, I'd like you to please try the examples on the next page. I think there are 2. Woo! So take a moment, give them a go. You'll probably want to give yourself like a solid 10 mins, maybe. And then after that point, please just resume the video. I'll go through them kind of quickly-ish because the expectation is that you've attempted them already. And then you can check how your solutions went. Check for similarities, differences. We might isolate different radicals first. Which one you choose is up to you, but we should get the same end result and the same roots to verify. And pause the video now. All right, I'm assuming you paused and restarted. So, tackling 4.6b, which you've all attempted at this point, I'm just going to add 3 to both sides. So left side, I don't like that root. I've got the root of x plus 2. Right side, I've got the root of 5 minus 2x plus 1. And that's again from adding 3 to both sides to get rid of that negative 3. Now that a root has been isolated, I'm going to square both sides. Note also, like this stuff in pink, remember you don't have to show that. You don't have to show that you're squaring both sides, you just have to do it. Granted, if you actually write this part, you write that you're squaring both sides. That's what the mark is actually for. So if you get this far, you've got a 1 out of something. If there's extraneous roots, we'll add to the mark total. This is either 3 or 4 marks. We'll find out. All right, square left side, x plus 2. Square right side, I've got the first thing squared. I've got the second thing squared, and in between, 2 times their product. Boom diada. All right, I'm going to move a bunch of stuff to the left side. All this highlighted stuff I'm going to get away from the right so that I can isolate the radical. So I've got x plus 2x is 3x. I'm going to take this 2, I'm going to subtract 5, and then I'm going to subtract 1 more. So that gives me negative 4 total. And this is the scenario we've got. A radical term is isolated. We can square both sides. And just by doing this, now we've attained 2 of the marks. Oh, except not really, because I didn't put a 2 on the left side. Now I've got 2 of the marks. All right. Square the left side. 12 times 2 is 24. 4 squared is 16. Square the right side. We've got 4 times 5 minus 2x. I'm going to pile everything onto one side. 9x squared. Here we've got negative 24x, and this is negative 8x on the right side, so I'm just going to add 8x to both sides. We've got 16, and then 20 is on the right side. I'm going to subtract 20 from both sides, leaving me with that. This is hopefully factorable. The inside and outside pair either both have to be odd or both have to be even. Let's guess even. See what happens. We're not dealing with 3s. We're probably dealing with like a 9x and an x. And yeah, that. So outside is negative 18x, inside is positive 2x. That gives us the negative 16x we're after. Huzzah. Make sure you keep this as an equation. Right now this is an expression. I need to throw in that equals 0. Don't want to get that communication error. And now x is either negative 2/9 or x is 2. Those are the possibilities. We've gotten 3 marks. I'm mostly certain this is a 4-mark question. I'm sure one of those is going to be extraneous, but let's find out. So first thing, let's verify one of them. I might start with the easier one. Oops. Verify x equals 2. We'll check left side. We'll check right side. We'll see what we get. Right side was, oh, they were both gross. Okay, left side. Root of x minus 2 minus 3. And the right side was root of 5 minus 2x minus 2. I'm mostly certain of that. And we'll plug in x equals 2. Neat. Looks like x equals 2 is a winner. Super duper. They could both be winners. So we do still need to, we can't just be like, oh yeah, that means this one's wrong. We do actually need to check it. So let's verify. I can spell. Nailed it. X equals negative 2 over 9ths. 2 over 9. Left side, root of x plus 2 minus 3, which means that the left side is the root of negative 2 over 9 plus, I'm not going to write that as 2, just for performing fraction operations, I know I'm going to have to add these. I might as well take it in this step to say 2 is the same thing as 18 over 9. And I'll subtract 3. So we've got the root of 16 over 9, which is 4 over 3, minus 3, and again, might as well get a common denominator here, that, which gives us negative 5 over 3. Okay. Right side was the root of 5 minus 2x minus 2. 5 minus 2 times negative 2 over 9 minus 2. The root of, okay, negative 2 times negative 2 over 9 is positive 4 over 9. And 5 is the same thing as 45 over 9. So that's the root of 49 over 9, which is 7 over 3. And we're subtracting 2, which is 6 over 3. This is 1 over 3. Uh-oh, SpaghettiOs. That one does not work. So we go back here. We show that even though this first solution was attained, we reject it. It is very clear what the solution was. I can still read that it was negative 2 over 9, but there's a big X saying it has been rejected. And then this one, for safety's sake, we can put a box around it to be like, you're protected, you're treasured, you're a good solution. Thank you, solution, for being there for us. And what was that? And last one. Whoop. Radical's not isolated. I'm going to subtract one of them. I don't know which one. We'll see what happens. Whoops. That. I'm going to square both sides. So there I've gotten a mark. I'm going to pile everything onto one side somewhere. That doesn't really matter where. Got negative 2x from those. And then 5 minus 4 plus 3 is 4. And I could square both sides from here if I want, but I'm noticing common factor. They've all got a common factor of 2. So, actually, no, I'm just going to divide by negative 2, so I don't have to deal with as many negatives. Get that going. And now I'll square both sides. We've gotten 2 marks so far. Let's pile everything to one side. 4x minus 4x, sorry, negative 4x minus 4x is negative 8x. And then 4 plus 12 is 16. So this gives us just the one possible solution of x equals 4, only one thing to verify. At this point, we've gotten 3 marks. We'll find out if it's a 3 or 4 mark question by verification. But on a test or quiz, you will see the mark value associated with it, and you can use that to kind of give yourself hints as to what to expect. Oopsie daisies. So we're going to verify x equals 4. Let's check the left side, which was a lot. Got it. And right side was 2. And when x is 4, this is what we've got. This is root 1 plus root 1, which is 1 plus 1, which is 2. Super duper pooper scooper. This solution works. It is not extraneous. So this was just a 3-marker question. Again, use those to kind of give yourself hints as to what to expect to do in the question. If you see a single radical term, like the stuff from previous lesson, squaring both sides is worth 1 mark. If you see 2 radical terms, then for sure you get 2 marks for the 2 times that you have to square things. You get another mark for your method of attaining the actual value of the solution. And then if there's an extraneous solution, that's going to put up an additional mark. Stuff in pink, remember, you don't have to show it. If you are asked to verify, then you do need to show the verification process. You do need to have things separated into a left side and a right side with no equals signs going between here. Just completely separate entities, because we don't want to say something like all those things are equal, because they're not. And that's about that. What a great unit. What a radical unit. Nailed it. I shouldn't make myself laugh when I cough. If you have questions, please reach out. And at some point, we'll probably have a quiz and a test. But we'll talk about it. Be good to yourselves, be good to one another, and do all the practice work. The